Hey, so Unit 4, solving systems of equations. So, little trip down memory lane. We've got a variety of ways in which we can solve systems of equations. And the power of a systems of equations is we've got two different scenarios that are going on. And then we can kind of figure out like when we can maximize one thing versus another. And then we can also just find, in this case, like, hey, when are they equal to each other? So, three different ways as we kind of look ahead there is you're going to have your substitution, you're going to have your elimination, and then what we're focusing on here today is your graphing. So yeah, so we're going to graph here. So to solve it by graphing, we simply graph both lines, and then we find where they intersect at. So we do have things because, like I just said, where they intersect at. So where the lines cross. Now, here's the thing: is when they intersect. All right, that's what we call one solution. All right, so it's just at that point, that ordered pair. And but then sometimes like other things happen, like we graph the line, and then when we graph the other line, it's actually the same line, so they're right on top of each other. Remember, the solutions are based on where they touch at, and so if they overlap, they touch everywhere, which means it's going to be an infinite number of solutions. And then sometimes we get parallel lines, so they never intersect, they never cross, so then we've got no solution here. So yeah, let's jump into it. It's like it says, write them in slope intercept form, graph them, and simply like where do they cross at. So let's go after someone like problem number 1. All right, the first line, y equals negative 2x. Okay, so that's nice. It's in slope intercept form. So here we are. We are at our 0 for our y-intercept, because technically it's a plus 0. Our slope is negative 2, so negative 2 over 1. So I'm going to go down 2 to the right 1, down 2 to the right 1, all right? Or, remember, it could be 2 over a negative 1, which means I can go up 2 and to the left 1. What we want you to notice here is they're all on the same path of points. So ruler is definitely nice. You know, I'm going to do my best here. Certainly something just to make your life easier. The other portion, it's not in slope intercept form. So we're going to divide both sides by 2. So we've got y equals 2x. So in this particular case, yep, right away, oh, there it is, dead giveaway. Now, again, I'm still going to graph up 2 to the right 1, up 2 to the right 1. But yeah, these both cross at the ordered pair 0, 0. That's how you will write out your answers, all right, in that ordered pair form. Let's find someone that does a little bit more for us. Problem number 3. Now, we are in standard form here, but here's the thing, people. Standard form isn't the best for graphing in because so many times we get fractions for the intercept. So I'm always going to encourage you to put it into slope intercept form. That's the best way to stay with whole numbers and to stay on the grid that's there. So the top parts, let's subtract the 2x over. So I've got 3y equals negative 2x plus 10. And then we're going to divide everyone by 3. Now, again, sometimes it's like, dang it. I got fractions. Oh, okay. I mean, we just kind of have to deal with it at times. So y equals, ooh, that is a y, negative 2/3 x plus, and then this is 10/3, okay? Now, the thing about this is like, okay, 10/3, all right, so that's 3 1/3. So yeah, we're going up 3 1/3. Like I said, oh my gosh, like I don't, again, this is part of the problems with graphing is like we get fractions. So um, let's let's hold on for one second here. All right, just because I know where this question's going. So let's go to the other one. All right, let's subtract that 4x over. So we've got 6y equals negative 4x plus 12. Let's divide everyone by 6. Do you see it? Do you see what's going on here? Y equals negative 4, 6. Oh, isn't that negative 2/3? Yes, it is. So why this is so special is check out the slopes right away. The slopes, they're the same. When slopes are the same, they are, I think I heard it. Yeah, parallel. So these are going to be parallel lines. One of them starting at 3 1/3. The other one starting at the 2. Now, again, we can kind of just graph it here, a little bit. The down two, to the right three, so we know we're going to be parallel lines. So, yeah, like, let's not get too much into it here. Parallel lines, no solution. All right. Now, again, this is why we have other techniques. If we've got fractions involved, we're going elimination, we're going substitution there, which we'll get to all of that. So, yeah, there we go. That was nice, right? Okay, example of no solution. Let's find ourselves another good one. That one's okay. We're not interested in that. Okay, not bad. All right, yeah, let's go down to, problem number 5. All right. Okay, so let's rewrite in slope-intercept form. So let's subtract that x over. So we've got ourselves 2y equals negative x plus 3. All right, we're going to divide everyone by 2. Okay, so, oh man, fractions again. All right, like I said, this is why we have other techniques. Negative 1/2 x plus 3 halves. Like, okay, let's just hold on a second here. I'm just not going to graph, okay? Because I've got x equals 5. And so remember, x equals 5, that is a vertical line, yes, going through 5. So we're here, so we know we are right there. So that's a nice one to graph. Let's start getting into this here. 3 halves. Now, this isn't as bad as we think because 3 halves is really 1 1/2. 1 and then a half that's there. So with our slope that we're looking at, we are going down 1. So, okay, so we're in between, and then we're going to the right 2, right here. There we go. Down 1, so we're halfway in between, and then to the right 2. There we go. Down 1 to the right 2. Okay, here we go. Now, again, if we kind of graph this there as I get in there, because I want to try to make this a nicer one. Oh, that is not nice. That's there. Okay, this is, oh man, there's 3-year-old self that's there drawing, that's there. But yeah, we can see, and this is it. Again, we want to show you why, like in general, graphing isn't something that we use too much, all right? It's a good visual, all right? So, yeah, we're going to kind of look at there. That is the order pair 5, comma, -1. Now, this leads into something else we want to show you. And the last thing that we want to show you is that, listen, if you're not sure of the ordered pair, like I said, graphing really only works with whole numbers. If we've got fractions involved, like where it crosses at, you can't look at the graph and be like, well, that's clearly 2/3 or maybe that's 5/6. You can't make that. So what we're gonna do here is we're actually gonna plug it in and see what works here. So like in the equation x equals 5, plug in the x. Well, the x is 5. Does 5 equal 5? Yeah, so that works. So here's what we're after is in this x plus 2y equals 3. We're curious that if we plug in the x and the y, do we get a true statement? So x is 5 plus 2 times -1. Oh my goodness. 5 minus 2, that's 3. We got ourselves a correct answer. So we can plug it in and see if we get true statements. If we do, jackpot, we know it's locked in on it. So again, graph them, find where they cross. Listen, if they're not whole numbers where they intersect at, we ain't using graphing. So it's a nice technique, visualize, but really where it's at, substitution, elimination, that's really where it's at. So there you go. We're set. Graphing.